Welcome to everybody. Welcome to my YouTube channel, MadLab. Okay, today let us talk about partial fractions. Yes, fractions. So, general introduction. A fraction in the form 5x minus 1 all over x minus 2 times x plus 1 can also be written in the form 2 over x plus 1 plus 3 over x minus 2. And this other form is called the partial fractions of the original fraction. Okay, now there exist many types of partial fraction decomposition. Each of the types depend on the form of the fraction. Okay, so they are of many forms. Yes. Now we have the type 1. The type 1 said that when the fractions, okay, of the form f of x over g of x, where the degree of f of x is less than the degree of g of x, and g of x has a linear factor. For this case, to decompose, we just use a simple type 1. Now, how does this comes about? For example, let us partial fract. This is our main fraction that we had as in the introduction. Okay, we have it here. So to do this, we first of all have to let f of x be equal to our fraction. Okay, so this implies that this fraction will be equivalent to what? A all over x minus 2 plus b all over x plus 1. Since these are linear factors, you just have to take any constant a all over the first fraction, all over the first bracket, plus you just always put a plus. Don't have to put a minus. They don't use any other sign. Okay, since we don't know what is the value of a, what is the value of b, because we want to partial fract, you just put a plus sign in the middle. At the end, if the value of a is different, we're just going to change everything. Okay, so we get this. We add them, and we have this. Now we realize that the denominator are the same, and if the denominators are the same and these functions, these two fractions are equivalent, we just have to equate the numerator. So this will imply that 5x minus 1 equals to a into x plus 1 plus b into x minus 2. Okay, now for this particular case, without wasting too much time, you can let your x be equals to negative 1 and 2. If you let your x be equals to negative 1, you have to eliminate. You see that a will be eliminated, because it will be negative 1 plus 1. You give a 0, a is eliminated. You replace negative 1, you're going to get negative 3. You have now negative 5 minus 1, you get negative 6. So simplifying, you are going to have your b to be equals to 2. Now when x equals to 2, you replace it here, you eliminate b, and you get this. Now there are many types of solving this. Once you have already attained this level of equation, you can either open your bracket, simplify, get the equations, solve them simultaneously, or you can just substitute. Okay, so it depends on the case. In some cases, you cannot even see what to substitute. Okay, so the final fraction, always to think to note, always put back at the end your final fraction. Yes, that's when they see that you have done something. Okay, so finally your f of x will be equal to what? 3 over x minus 2 plus 2 over x plus 1. Okay, a is 3 and b is 2. So you just have to replace the values. Let us now pass to the next part, or to the next type. Yes, let us pass to the next one. So now let's talk about type 2. So fractions of the form f of x over g of x, where the degree of f of x is less than the degree of g of x, and g of x has repeated factors. Okay, when we talk about degrees, we talk about the power of x. Okay, so when the power of x in f of x up is less than the power of g of x down, then we can proceed with the type 2. Okay, and that g of x have repeated factor. For example, let us partial fract this 3x minus 1 all over x into x minus 1 all that squared. So this term actually is a repeated factor. And as I was talking of degree, you can already see that the degree of x up is x is 1, and the degree of x down is x cubed. X squared from this expansion and times this other x, you can get x cubed. So you can already see that f of x, the degree of f of x is less than the degree of g of x. Now let us get to the solution for this. So we let f of x be equals to this 3x minus 1 all over x into x minus 1 squared. Now this will be equivalent to what? This is how we decompose this type. We have a all over x, that is the first part, the first coefficient, the first value down, plus b all over x minus 1. Since the function is repeating, we just have to add it again with another constant all over x minus 1. All that we square now. Okay, because of the repetition, we have to take this one for b, and we add again another c, we square it. Now this one will be equivalent to what? You add all of this, you have the denominator always be equal to this other one. Okay, it's the same. If you take x times x minus 1 and then you just see that this factor is repeating this other, is a repetition of this other factor. So I'm just going to get x into x minus 1 other squared. You simplify, you get this. Now you equate again normally, and you have 3x minus 1 to be equals to a into x minus 1 other squared plus bx into x minus 1 plus cx. Okay, now for this particular case, is you let your x be equals to 0, 1 and 2. When your x equals to 0, you discover that b will be eliminated with c, and you can get already a. So you have 0 into negative 1 squared. You square, you get 1. You put 0 here into negative 1. So your a will be equals to what? Negative 1. Okay, you do same. Now when you let x equals to 1, b will disappear and a will also disappear. You're just going to be left with c. Okay, replacing the value of 1 here and simplifying, you're going to get your c to be equals to 2. Now when you let your x be equals to 2, you will discover that what? You discover that all these different fractions will do, these different parts will remain, nothing will be eliminated. Okay, so you get an equation. Now with that equation, just since you have already the value of a and c, you replace it in the final equation and you're going to get the value for b, and b will be equals to 1. Okay, voila. Now the final answer for this case is f of x equals to negative 1 over x plus 1 over x plus 1 all over x minus 1 plus 2 all over x minus 1 all that squared. Okay, so as I said, when you're writing your first decomposition with unknowns, don't attribute any sign apart from the positive sign. Okay, because at the end you always get the correct sign. If it is supposed to be plus, it will remain plus. If it's supposed to be negative, it will change to negative, just like the case of a. Okay, so we have this. Now let us run directly to the next part, or to the next type. Voila, type theory. So for the type theory, fractions of the form f of x over g of x, where the degree of f of x is less than the degree of g of x, and g of x has a quadratic factor which cannot be factorized. So actually the g of x is a quadratic, but that you cannot factorize. Okay, so we have this. For example, let us partial fact x all over x minus 2 into x squared plus 1. So that's our quadratic that we cannot factorize. So let's have the solution. We let f of x be equal to our fraction. We now this function now will be equivalent to what? A all over x minus 2 plus b all over x squared plus 1. Oh, I think there's an error here. I think. Because normally when you're doing your partial fraction decomposition, the degree of x up must be one less than the degree of x down. Okay, so for this case, we are instead supposed to have bx plus c, yeah, bx plus yes plus c all over x squared plus 1. Okay, so this one is it's an error. Okay, just note you instead have a all over x minus 2 plus b squared bx plus c. Okay, you're going to get 3 fractions for this case normally, I think. Yeah, so you will do that, please. You do that for me and you add them. You simplify normally and you can either substitute or you expand. You simplify, you get value for a, b and a c, and you tell me what is your final fraction in the comment sections. Okay, please. Okay, so let us move to the type 3. Yeah, let us move to the next one. So for this other case here, it's another typical case now where the fraction of the form f of x over g of x, where the degree of f of x is greater than or equal to the degree of g of x. Straightforward. If the degree of f of x is greater than or equal to the degree of g of x, then we talk about the type 4. So let us have an example. We have x plus 1 all over x plus 2. Okay, so for this case, you can already see that the degree of x up equals to the degree of x down. So how do we decompose this type? So for the solution, you will let f of x to be equal to x plus 2 all over x minus all over x plus, it should be x plus 1 all over x plus 2. So this now will be equal to what? Now to solve this, you have to do long division. Okay, you have to do long division. You can do either synthetic division or long division, but you need to simplify the fraction. So you're going to get x plus 2 as the divisor and x plus 1 inside. So you have to do you perform the long division. You have a value up here and a remainder. Okay, so you now rearrange or rewrite this function in this form. You first of all have to copy what? The value up, that is the 1, minus what? Or plus the remainder all over the divisor. Okay, since the remainder was negative 1, that's not why we have a negative here. And since now this fraction resemble a simple, you have already been partial fracted. Even the example was very small. Yeah, you have already been partial fracted, so that is the final fraction. So you can see for the type 4, first of all I have to perform long division. Now in the case where your degree of x up here now is more than the degree of x down, once you will have to do the long division, you discover that at the end here, after you have put this other coefficient, this other value here, the other fraction here now will be just like a type 2 or a type 1, where you have again to partial fract, okay, and get the other fractions. Okay, in other videos when we are going to be solving exercising on this again, or past this, you're going to see how to apply more of this, because the more you apply the more you learn. Okay, so I thank you all guys for watching. Okay, so like, comment, share. Please don't forget to subscribe to my YouTube channel. Okay, because more and more are still to come. Okay, so I thank you again for watching. See you in another video. Yes, thank you.